Hello, myself Naveen Kumar Saini. Today I am going to give the one lecture that is based on the Bluetooth technology. So before going into deep analysis or deep discussion about the Bluetooth technology, we will go through this presentation by this flow. In this flow, there is an introduction, Bluetooth architecture, Bluetooth applications, protocol stack, radio layer, Bluetooth link layer, Bluetooth frame structure, and so on. So first of all, we must know what is the Bluetooth. Bluetooth is nothing but this is the short range wireless communication system, which is the replacement of the wired system, in which for the short distance, if we want to communicate with the different devices, so these devices can connect with each other. So this Bluetooth is designed by the different companies. So this is the group of the SIG, that is the special interest group. So in this group, there are different companies are incorporated. That is the first is the Ericsson, IBM, Intel, Nokia, and the Toshiba. So by formation of this network, that is a Bluetooth, is designed by these companies, different companies. And the name was given that terminology, that is a Bluetooth, that is a Harald Blattland is called the Bluetooth. This was a king in the year 942 981 in this range. So if we talk about the different versions of the Bluetooth, so this is started in the 1999. So this version was the Bluetooth 1.0. So the features for this first version was, it was completely based on the data rate. Obviously, when we want to communicate with the different devices, so we want to transmit the data. So at the first version, the data rate was less than 1 Mbps. And here the pairing of devices was there by transmitting different signals, so that the other devices can communicate with the one devices. So in this kind of network, there was the one master device and others were the slave devices. In the version 2, that is Bluetooth 2.0 in 2004, which provides a higher data rate with the EDR, that is enhanced data rate, and it was up to the 3 Mbps. So as we know, as the different versions of any of the technologies came into the picture, so in that the main goal is to improve the data rate and to reduce the ISI intersymbol interference or the loss of the data. So in the next version of the Bluetooth, that is Bluetooth 3.0, so this was introduced in the 2009, and another the feature for that one, or the characteristic for this version was the high speed, that is the HS mode, using the 802.11 Wi-Fi for the faster data transfer and up to the 24 Mbps of the data rate. So this was the highest version in the version of Bluetooth 3.0. In up to December 2009, next version of this Bluetooth was Bluetooth 4.0, and it was completely focused on the low power operations for the sensors and the IoT devices. In the next version of this Bluetooth, that is Bluetooth 5.0 and 6.0, this was December in 2016. It was designed or dedicatedly designed for the Internet of Things kind of devices. So which offered the improved range, speed, efficiency, or the low power sensors. So this for the short range communication system, the another technology which was introduced into the Bluetooth also, that is a MIMO as well. That is a multiple input, multiple output. So if we talk about the architecture of the Bluetooth, so the Bluetooth architecture is comprised in the two ways. First one is the Piconet. The first is a Piconet. In that Piconet, when we have the one of the master device, and others are which are communicating with this master device is called the slave devices. So in the previous versions of the Bluetooth, the maximum 7 devices was as a slave device which can communicate with the master devices. So this is the one of the Piconet. Okay, so when we have the multiple Piconets in the network design, then we see the one Piconet and the other Piconet and the third Piconet and so on. So when we have the multiple Piconets in the network, So we call that network as the scatter net. So in that way we can say that two architectural viewpoint is for the Bluetooth is first is the piconet and second one is the scatter net. So scatter net is nothing but this is the group of the piconet. So in this way we can also see that one of the slave in the scatter net can be act as the master for the another piconet. Okay. So in this way the different multiple devices can connect with each other, and here the multiple masters will be maybe there, and the slave can be act as the master as well if that slave is this slave is a master for the another piconets. If we in the one tier, if we have the different devices which are connected with this, so in this way this slave will be act as the master at another one time, and the rest of the devices may be the slaves for that. Okay, so multiple slaves can be connected in that network is called the scatter net. So in the scatter net we have the another way or another mode of the device can be connected, that is the parked slave. So this parked slave is used for connection into the network, but these are not connected, or this will be only into the parked mode, it will not be into the active mode. So this is the mode of operation for the scatter net system. So if we talk about the basics of this piconet system, so in this piconet system that consists of the one master node as I said, and we have the up to the 7 active slave nodes. This is up to the range of the approx 10 meters and more or the 50 up to the 50 meters. So the responsibility for the master, that is to control the clock and the synchronization of the different devices which are connected in the one piconet network. So the another feature of this master is also that the time synchronization and the frequency synchronization both with the active user, that is at the one time is connected with the master. Okay, so this piconet is completely based on the master slave based networks. So okay, so in this the direct communication is also be there between the slaves, which is maybe not allowed at one time of instant, but it may be allowed with the after some time of instant. So the one device can be connected with the master at one time, and another time another device can be connected with that one. So for that reasons for the master and slave design is to make the Bluetooth chips simple and inexpensive. That is what is the meaning of that one? In that way the slave device, as I said, this slave device can be connected with the master, and these different slaves of that master can be communicated with another piconets. Okay, so in this way the network cost must be, we have to reduce that one. If we have the multiple masters in the different networks, then in that case the cost of the devices will be more. So that is why this connection or the deployment of the these devices are in that way that the another masters or the slaves can be act as the masters or the slave respectively. So so this slave devices, the characteristic for the slave devices is to follow the master's instructions, as the masters, as I said, masters are responsible for the clock synchronization with the slaves. Okay, so at the clock synchronization means at the different time slots the master can send the synchronization signals or the payload signals. Okay, so in that way this master slave have to define slave has to work in that way as the instructions were received from the master devices. So these master devices can be your, that can be maybe it can be your laptop, it may be your mobile phone, it may be earphones, earbuds. So any of the devices can be act as the master at one time, and the same device can be act as the slave in the another time of the network. So when we talk about the scatter net, So in that the collection of interconnected piconets all called the scatternet of the network, and device may be act as a slave in the one piconet and can be act as a master in the another piconet network, large network. So in that way the flexibility of the network will be increased. So if we talk about the talking about the nodes, so one kind of node is the bridge node. So this is the common device that participates in the multiple piconets. Okay, so this piconet in that way, just like if we have the one architecture of the one piconet and we have the another architecture of the second piconet, this is architecture of one piconet, this is the architecture of the second piconet. So in this way, if any device which is connected into the overlapping of the first and second piconet, so this device is called, or the node is called the bridge node. Means at the same time this node will communicate with the master, and this can be communicated with the another master master of the another piconet network. So this kind of architecture is deployed into the large area, and this will be beneficial to increase or enhance the data rate and the using the different nodes efficiently. So another type of nodes are the parked node. So these parked node devices are that are registered with the piconet, but these are not actively participated. This will be into the part of the piconet network, but it cannot be actively participate with the communication of the devices. So in the one piconet network, we can have up to the 255 parked node in addition to the 7 active slaves. As I said, in the one piconet network, we have one master and the 7 active slave nodes. But in the we can also park about 255 nodes that can be registered with the one master node, but it cannot be actively participate for the communication with the master node. So these parked nodes are switched to low power mode, means inactive or idle mode, to reduce the battery consumption. So in the parked state, a device cannot transmit or receive data, but it can respond to activation or the beacon signals from the master. Okay, so the data cannot be transmitted through this parked node, but all the controlling signals, all the synchronization signals can be transmitted or received by this parked or the slave nodes into the piconet system. Now come to Bluetooth applications. So these Bluetooth applications are characterized in the different ways, just like generic access applications of the Bluetooth is that comprises the procedures for the link management. So these Bluetooth applications are based on their application in the real life and their stack management. Based on those these two categorization, these applications are there. Just like first one is the generic access, second one is the service discovery. So in this service discovery, protocols for discovering which offer the services like serial port, that is replacement for a serial port cable, generic object exchange, which is defines the client server relationship for the object movement. Next application is for the lane access. In that, the protocol between a mobile computer and the fixed lane is there. Dial-up networking, which allows a notebook computer to call via a mobile phone. Next application for that one is the fax machines, which allows a mobile fax machine to talk to a mobile phone. Just like we transmit, we can take the print through this, or we can send the fax through the fax machines by the Bluetooth technology. Cordless telephone, which connects a handset and its local base station. Intercom, digitally walkie-talkie. Handset, intended for the hands-free voice communication. Object push, which provides a way to exchange simple objects. File transfer, which provides a more general file transfer facility. and the synchronization, which permits a PDA to synchronize with the another computer networks. So these all the some applications for that. Next we have the Bluetooth protocol stack. So this Bluetooth protocol stack is divided by this host controller interface, which is defined, which bifurcate this complete protocol into two parts. First, in the lower part is called the physical layer, and upper is called the next is the data link layer. So this again the data link layer is comprised in the two parts. First one is the L2 CAP, which is in the upper section of the host control interface, and the link manager, this is the lower part of the host controller interface. And the physical layer is responsible for the radio interfaces or the radio accesses. All the radio access phenomena occurs into the radio part, that is like the modulation, synchronization, data transmissions, payloads. So all are taken care by the radio access part of this stack. Then link control or the baseband control management is responsible for the transmission of the create the linkage between the physical layer with the data link layer and the upper layer of the ISO profile. And in the upper layer is also responsible for the RF communication and the service discovery. So so that this Bluetooth devices can be connected with the another devices. So this service discovery, this part is also responsible for the any of the device to make it as the master device or as in the slave devices. So these devices bifurcations can will be taken by that one. Then we have the different profiles of which are connected, which connects the upper layer and the lower layer in the Bluetooth protocol stack. So that's a functionality of these host control interface, link control, radio, RF communication, service discovery. This will be discussed in this way. The first one is the Bluetooth radio layer. So as I said, this Bluetooth radio layer is completely responsible for the transfer of the data between the master and the slave devices. And this Bluetooth technology is also be work on the different frequencies, just like the one ISM band frequency is the 2.4 gigahertz. So this Bluetooth also work on 5G gigahertz, that is also the one ISM band ISM band frequency range on which this Bluetooth will work. So these frequencies are used by the different applications of the Bluetooth. Okay, so for the transmission of the data, the transmission technique which is used into the Bluetooth radio link, that is the frequency hopping spread spectrum technology. It is also called the FHSS, which is used to minimize and allow coexistence with the other wireless technology in the same brand. So as we have already discussed in the previous lectures about the SSM, spread spectrum modulation technique, in which the technique which was used, that is DSSS, and we bifurcated that in the terms of the FHSS and the THSS. So this frequency hopping spread spectrum is one useful, so that any intruder cannot be fetch the data from the transmission of the duration, the transmission of the data. And in that the modulation technique which is used into that, in the frequency hopping spread spectrum, the different frequencies are allocated at different for transmission of the 1 bit. So if 1 bit is there, so if you want to transmit the 1 bit or the 1 symbol of the data, so that 1 symbol of the data will be transmitted with the different frequencies. So intruder cannot find that which frequency by which frequency the data is modulated. So this is the phenomena in the frequency hopping spread spectrum technique. So the available band which is into the FHSS, that is split into the 79 channels, and the bandwidth of this each 79 channels are 1 megahertz each. So the system can hop frequencies up to the 1600 times per second. So this is the hop rate of the FHSS, through which the any of the symbol can be transmitted, and it can use the different frequencies as for the modulation techniques. So the rate of that hop rate of the frequencies is called the that is the 1600 times per second. Okay, so each hop that is a dwell time which is lasting up to 6 to 5 microseconds. So means for this, any of the message or the symbol can be hold at the one frequency that will be hold up to the 625 microseconds. After that, the hopping will takes place. Means at every hop, it will hold up to the 625 microsecond for the symbols. So all devices in the same Bluetooth network, that is the Piconet, which follows the identical frequency hops and organized by the master's timing and the shared pseudo-random hop sequences. So in the FHSS also, as I said, the different frequencies are used for the hopping of the signal. So how we design this different frequencies? So selection of these different frequencies are completely based on the codes that is called the pseudo-random codes. So if we have suppose we have the 9 codes like 1010 1111, like 1 2 3 4 5 6 7 8 9. So in that way 110 will be allocated one of the frequency, that is the F1. If we have 011, so in that way this code will be allocated the frequency F2, and 101, in that case the F3 frequency will be allocated for that particular pseudo-random code. So in this way, these different frequencies can be allocated for the hop sequences. So these hop sequences will be known to the transmitter and to the receiver as well. Adaptive frequency hopping, further, which improves the coexistence Bluetooth dynamically, which avoids the channels experiencing the interference, such as from the Wi-Fi 802.11 or the other signals. So by changing its hop pattern to execute the problematic channels, thereby reducing the mutual transmission errors and maintaining the reliable communication. So this is very short range as compared to the Wi-Fi. Wi-Fi is for the long range communication, but up to the home. But Bluetooth is for up to one room. So these are short range as compared to the Wi-Fi. And that standard which was used for the Wi-Fi that is 802.11, and for the Bluetooth that is 802.115. So in the link layer, this link control or the baseband layer is there. So this layer is comparable to the MAC sublayer in the standard network. It transforms the raw bit stream into the frames and defines the essential formats for the communication. So master devices, which determines the time slots for the communication. The master device transmits even in even slots and the slave in the odd ones. So this complete time frame for the Bluetooth is divided into subframes, and in these subframes, these frames are divided into the slots, and in each slot, so these slots are divided into the even and odd slots. So the master in the Piconet can be transmit the signal through the even slots, but the slaves it will transmit into the odd slots of the time slot network. So the frame length, it can be scalable, that can be of 1, it can be of 3, it can be of 5 time slots for the network. And the frequency hops between the frames, but not during, making longer frames more efficient. So this is 135. These slots are for the initial version of the Bluetooth, but After that, we have the multiple slots which are dedicatedly used for the transmission of the data into the subframe. So this technique of transferring high, you can say, from subframes to the subframes and then to the time slots. Okay, so the transmission will be taken care by these different slots. So link manager protocol, which establishes logical channels called the links to transmit frames between the master and the slave devices once they have discovered each other. So these devices also be just like if we had a fixed structure of the network that one master and the different slaves, but we can have also the managed network in which any device can form self-configurable to the other devices at one time instant of the signals transmission. Okay, so this is a fixed structure of the Bluetooth devices, but we can have the mobile structures. So in that case, we call it as the managed system. Okay, so the before data transfer, the LMP manages a pair procedure to authenticate the devices for the secure communication. So in the old method, both devices use the same insecure pin codes, but in the new method, they have used the pseudo codes for the transmission or the pass keys for the transmission of the data. So for that purpose, they have used the FHSS technology for the transmission of the signals. So okay, so Bluetooth link layer. There are different type of links are used to carry the user data or the payloads. So two main types are synchronous connection oriented link. So feature of this synchronous connection oriented link is to use for the real-time data transmission, such as the voice or communication, and each SCO link is allocated a fixed time slot in the both directions. A slave device can maintain up to 3 SCO links with its master. So due to the time critical nature of the SCO link, frames are not retransmitted. So these are the features for this SCO, that is synchronous connection oriented system. So this this SCO is used for the forward error correction, which can be applied to minimize the error. Next is the ACL, that is synchronous connectionless link. So this asynchronous connectionless link is completely based on the packet switching, not the circuit switching. So that is transmitted at the irregular intervals, and it is used for operating the best effort delivery basis. And the feature of this ACL is to for the guarantee of the delivery of the data. So in this, but the frames may be lost and need to be retransmitted if the errors occurs. And the slave device can have only one ACL link with its master. Okay, so all data over ACL links is managed by the L2 cap, that is logical link control and the adaptation protocol layer. So this is the part of the upper layer of the Bluetooth sublayers. So the major functions of this L2 cap is it performs the segmentations, multiplexing, error control, and the quality of the service. So in this segmentation and reassembly, it breaks the large packets into the small packets, which is from the upper layer, and next is the multiplexing or demultiplexing. So which it also supports the multiple logical channels and allowing the data from the multiple sources. Error control and retransmission, which ensures the reliable communication, and through the error detection and the retransmission of lost frames. Quality of service, that is maintains the service quality by managing the bandwidth and the latency among the multiple links. So these are the features of the L2 cap layer, which is a part of the data link layer into a Bluetooth stack. So okay, so I hope you got the point about the Bluetooth technology. What are the physical appearance of this Bluetooth? That is the architectural point of view. It is divided in two parts. That is the piconet and the scatternet. Next, it works on the frequency that is 2.4 gigahertz, that is the ISM band. Next, the Bluetooth stack is divided into two parts, that is the first a physical and the MAC layer, and this MAC layer is divided into two parts again, that is the data link layer, which comprise the radio access and the L2 cap system. Okay, thank you very much.